So in this problem, we have an airplane flying due north with an airspeed of 500 kilometers per hour. There is also a northwesterly wind of 60 kilometers per hour. Find the true speed and direction of the plane relative to the ground. Now, when we're drawing the picture that corresponds to this, it's pretty easy that we have the plane that's going true north with a speed of 500 kilometers per hour. Now, when we say that we have a northwesterly wind, what we mean is that the wind is coming from the northwest direction. So the wind is coming from this direction. So really, we have a vector that's heading off in this direction that will be our actual wind vector. So when we put this together, we actually have a wind vector that's heading off in this direction, and since it's northwesterly, we know that the angle that this thing is coming off of is going to be 45 degrees. So we've got our wind vector that's heading off in this direction, we've got our plane that's heading off in that direction, and so our resultant is going to be our parallel plane vector. So our resultant is going to be this vector here that's heading off as the sum of those two vectors.
So we have the velocity vector for the plane as just 0, 500. Then for the velocity vector for the wind, we know that it's got to have a magnitude of 60 kilometers per hour. But then how do we get the angle? Well, the first component is going to be the cosine of whatever the angle is, and in this case the angle is negative 45 degrees because we're coming from the northwesterly direction, and so our angle with the horizontal is actually a negative 45 rather than just being a 45. And likewise for our y component, it's the sine of negative 45 degrees. So that whenever we put that in, we've got 60 times a positive root 2 over 2 and a negative root 2 over 2 for the y component. So when we distribute our scalar of 60, we end up with a wind vector of 30 times the square root of 2 for the first component and negative 30 times the square root of 2 for the second component. Our resultant then is just the sum of those two vectors, p and w, and so we have 0, 500 plus 30 root 2 minus 30 root 2, and so we have a resultant of 30 root 2 horizontally and 500 minus 30 times root 2 vertically, or giving us something that's approximately 42.4264 horizontally and 457.5736 vertically. Our speed then is just the magnitude of the resultant, which is just going to be the square root of our 42.4264 squared plus 457.5736 squared, or giving us approximately 459.5363 kilometers per hour. Now for the angle, they want the angle between the resultant and the horizontal. And so in essence, what we're doing is finding the angle between the resultant vector and the horizontal positive unit vector, which is really just I, given by the component 1, 0. So by our dot product formula, we have the resultant dotted with our vector I is going to be the length of our resultant times the length of our vector I times the cosine of the angle between them. And so what this really amounts to, because our I is going to be a unit vector, meaning that it has length 1, we know automatically that this is just going to be 1. Now when we do r dot I, then we are doing 42.4264, our second component, 457.5736, dotted with 1, 0, is equal to the length of r, which we said was 459.5363 times 1 times the cosine of our angle theta. Now remember, when we're doing the dot products, we are multiplying corresponding components, and we are just adding those together. But if we do our 457.5736 times 0, we just get 0. When we have 42.4264 times 1, we just end up our 42.4264 equal to 459.5363 times the cosine of our angle theta, or really being that theta is going to be the arc cosine of 42.4264 divided by 459.5363, giving us an angle of approximately 84.70 degrees. And so we have a speed of 459.5363 kilometers per hour at an angle of 84.70 degrees.